Welcome to another edition of the Carolina Bay of the Day, where we study the secondary impacts made by the glaciarized boulders that were ejected by an extraterrestrial impact on the Laurentide ice sheet. This is part 2 of a trilogy about the Carolina Bays of Hoke County, North Carolina. In this part, we will examine the elliptical geometry of the Carolina Bays and calculate the energy of the impacts that created them. The observation that the Carolina Bays have an elliptical geometry is not new. Almost 90 years ago, a paper published in 1933 by Professors Melton and Shriver from the University of Oklahoma characterized the Carolina Bays as having a smoothly elliptical shape and a peculiar rim of soil which is larger at the southeastern end of the bay. These two features are vitally important for determining the mechanism that created the bays, but they have been consistently ignored by the proponents of uniformitarian wind and water mechanisms for the creation of the bays. It would not surprise me if 100 years pass before geology books properly describe the Carolina Bays as having elliptical geometry. This is a LiDAR image of an area of about 26 square kilometers or 10 square miles near Bowmore, North Carolina. You will find a link to the LiDAR visualization tool for Google Earth by Michael Davias in the description of the video. The arrow points to a typical bay with a thickened rim on the southeast end as described by Melton and Shriver. A magnified image of the bay highlights the smoothly elliptical shape and the broad rim of soil on the southeastern end of the bay. The bay has a length of 681 meters, which is about 4/10 of a mile. Ellipses are conic sections, and for this reason, the glacier ice impact hypothesis published in 2017 proposes that the Carolina Bays originated as inclined conical cavities from the secondary impacts of glacier ice chunks ejected by an extraterrestrial impact on the Laurentide ice sheet. Then, viscous relaxation reduced the depth of the cavities to produce the shallow elliptical bays that we see today. The cover of my book, Solving the Mystery of the Carolina Bays, used this area of Hoke County to point out the elliptical geometry of the bays. Since the publication of my book in 2015, I have been disappointed that neither geologists nor astronomers have been interested in studying the Carolina Bays for their implication about an extraterrestrial impact in the Earth's recent past. This is one of the reasons why I have taken it upon myself to discuss the Carolina Bays. I want everyone to know that well-preserved Carolina Bays have an elliptical geometry and that they are mathematical conic sections. The elliptical geometry is not something that can be achieved reproducibly and consistently by wind and water mechanisms. The best explanation for the geometry of the Carolina Bays is that they originated as inclined conical cavities. Today I will focus on 4 bays numbered 1 through 4. I have been able to demonstrate experimentally that oblique impacts of ice projectiles on a viscous surface create inclined conical cavities that look elliptical when viewed from above. Based on this experimental model, we can estimate that the diameters of the ice projectiles that made the bays are equal to 1/5 of the bay lengths. This image shows the 4 bays fitted with ellipses, and the ice projectiles that made the bays are drawn to scale. The impact angle at which a bay was made can be estimated from the width-to-length ratio of the bay, which corresponds to the sine of the impact angle. Bay 4 corresponds to a cone inclined at 35.8 degrees, which creates a more elongated bay than the smaller impacts. Notice the width-to-length ratios of the bays. They average 0.639. This is additional evidence that the bays were not created by wind and water mechanisms. There's nothing to prevent terrestrial processes from stretching structures indefinitely, but this is not what happens with the Carolina Bays. All the bays had width-to-length ratios consistent with cones inclined at angles of 35 to 45 degrees. This group of Carolina Bays is approximately 1,056 kilometers from Saginaw Bay, which is the point at which the major axes of the Carolina Bays and the Nebraska rainwater basins converge, and which is presumed to be the point from which the glacier ice projectiles were launched. Knowing the launch angle and the distance between the launch point and the target, we can calculate the launch speed using ballistic equations. The launch speeds for these bays are between 3.2 and 3.3 kilometers per second. That is about Mach 9 or 9 times the speed of sound. We can determine the mass of the ice projectiles by calculating their volume and multiplying by the density of ice. Finally, we can calculate the kinetic energy of the impact using the mass of the ice projectile and its velocity. Notice that all the energies for these 4 bays are in the megaton range. The small bay number 1 was formed by energy equivalent to 1.51 megatons. This is 100 times the energy of the bomb dropped on Hiroshima. Although the impact speed is fairly similar for all these impacts, the energy increases dramatically depending on the projectile size. The reason for this is that the mass of the projectile increases in direct proportion to the cube of its radius. Bay number 4 was made by an impact with energy of 89.6 megatons of TNT. That is a huge amount of energy, but it is the energy required to punch a hole in the ground with a width of 1.5 kilometers and a length of 2.6 kilometers. By comparison, the Tsar Bomba, which was the most powerful nuclear weapon ever created and tested, had a yield of 50 to 58 megatons of TNT, which is significantly less than the energy to create Bay number 4. The energy associated with the creation of all the Carolina bays and the Nebraska rainwater basins was so huge and covered such a large area that the ballistic sedimentation that created the bays has to be associated with an extinction event from the Rocky Mountains to the east coast of the United States. The thickened rim of a bay is created by the forward momentum of the overturned flap that is formed by the penetration funnel. This feature becomes more prominent when the impact happens on ground that has been softened by previous impacts. The photograph of an experimental impact shows that the overturned flap is pushed forward in the direction that the projectile was traveling. This creates a thickened rim on the leading edge of the impact cavity after viscous relaxation. Thank you for joining me in the investigation of the Carolina bays. I will continue to examine the Carolina bays one bay at a time. My book about the Carolina bays is available at Amazon. The next episode of the Hoke County Trilogy will examine overlapping Carolina bays and try to determine the geological mechanisms that created them. Please subscribe to be notified of future videos about the Carolina bays.